Okay, so I know you guys took your quiz yesterday. Haven't not had a chance to look at it just yet. I was out sick. I'm still not feeling great, but I am here, so that's the good news. We are starting a new unit today. We're going to be graphing quadratics. So far this week, this is the last day this week, but next week we are going to graph, and we're going to have a quiz on Friday next week. So that's where we are with things. So we are starting today just graphing. This is in your notes, day 46. So let's get going. So remember in our last unit, we talked about there being more names for x-intercepts than just the x-intercept. What are some other names for an x-intercept? Yeah. Zeros. What else? Yeah. Roots. What else? One more, Tara. Solutions. Now there is just one subtle difference here. In general, when I list an x-intercept, I write it as an ordered pair. Everything else, I simply list the values that cause my function to be 0. Make sense? Okay. So I want you guys to have Desmos on your iPad. If you have not put Desmos on your iPad, take a minute and get it from self-service. I think probably for the most part, everybody has that. Good, Aiden? Perfect. Okay, so before we put this into Desmos, I want to talk about how to find the zeros. So if I want to find the zeros from a function, I set it equal to 0 and I solve. If I can factor, I definitely factor. So I need two numbers that multiply to -8 but add to -2. Any ideas? Yeah. 4 and -4. There we go. -4 and positive. Beautiful. Okay, so then we set our factors equal to 0. And we solve. So we get x equals 4 or x equals -2. And those are my zeros. And I just simply list those as numbers. How can I look at that function and tell what the y-intercept is? How'd you get that? Yeah, it's your constant value. Now remember, a y-intercept is a point on a graph. It is an ordered pair. 0 and -8 is my y-intercept. At this point, I'm going to put in the graphing calculator and see what happens. So I'm in Desmos. I have mine preloaded. So take a minute, put that in Desmos. Kind of take your phone out before you mess up, please. Desmos is pretty nice. It's user friendly. It's a nice tool to use, but just please know that if you are taking an ACT or an SAT, they will not let you use it. Therefore, you got to know how to use your graphing calculator too. So we're going to do a little bit of both. So one thing that's nice about Desmos is I can see there is a minimum there. So if I just touch it, it'll tell me the ordered pair. I can look at my x-intercepts too. Oh, it's because that's not x-axis. And it will tell me the ordered pairs as well. Okay, so of course I had zeros at -2 and 4. That should not be a surprise. And the minimum happens at 1, -9. So let's put that on our graph. If it's going to take upper pathway down. So now let's plot what we found. I have zeros at 4 and -2. I have another y-intercept at -8. And on decimals, we saw that we have that minimum at 1, -9. So this graph has a minimum. It occurs at 1, -9, but the minimum equal to -9. So if I want to know the minimum, it is the y value. If I want to know where it happens, it's the ordered pair. And let's draw this in for a minute. This is called a parabola. And that minimum point, the point where the minimum occurs, is called the vertex. So let's see. Does anyone notice anything interesting about where the vertex is versus where the zeros are? What's that?
It's directly in between.
Yeah, it's directly in between. That x value is the average of the zeros. So let's just check that out. My zeros are 4 and -2. I'd add them together and divide by 2. It's 2/2 or 1. Now, that's great. But how could you go about finding the y value that goes with that besides decimals? How do you think you could find this y value besides putting it into decimals?
Can't you just plug it into the function?
Plug it into the function and you get the y value. So f of 1 is equal to 1 squared minus 2 times 1 minus 8. 1 minus 2 minus 8 is -9. That is my vertex. Now, they're in a parabola. A parabola is symmetric, meaning I can fold it over and have it one side line on top of itself. The line of symmetry is called the axis of symmetry. And on this graph, it's right here. That is my axis of symmetry. And the nice thing about it is, if I know that my y-intercept's at -8, that means I have a point 1 to the left of that axis of symmetry. I'm also going to have a point 1 to the right of that axis. Make sense? The axis of symmetry is a line. And you would write it x equals 1, which is the x coordinate of the vertex. Any questions? Thumbs up, thumbs down, sideways on that. Okay. I want you to try this one. Do exactly what we just did for the last problem. Try this one. Sure. Okay. Who's there? Who? Who's done? Who's still working? Okay, come on. Otherwise. Okay. All right. So here are my answers. You guys have any questions? Good. Notice that this vertex, the X value is happening in the dead center of where those zeros are. Okay. Comes up, comes down, comes sideways. Beautiful. Okay. Let's see. Why don't you do this one now? Compare your answers with your neighbors when you're done. Who's done? Who's still working? Okay, let's give this a try. So this is what you should have gotten. It opens up. Axis symmetry is x equals -1. Y-intercept is -6. And do you guys have any questions? No, yes, maybe so. Kate? Well, one way would be to multiply all of this out and find the constant. The other way would be anywhere on your y-axis, x is 0, you can put 0 in. So that becomes 2 times 3 times -1 or -6. Make sense? Great, yeah,
Wait, so the axis symmetry is just the x value of the vertex?
correct,
Oh,
correct. Okay, anything else? All right, so some things that you need to know if you're graphing this without Desmos. What do you do? Well, you find the zeros. You can do that by factoring or quadratic formula if you have to, but you find the zeros. The next thing you do is you find your vertex. And the vertex, the x value of your vertex is the average of the zeros. And then you plug that value into your function to solve for y. That's your vertex. If your a value, this value right here is positive, it's going to open up. And if it's negative, it's going to open down. And you find the y-intercept and you graph. And then one more thing I should say is use the axis of symmetry. To find other points. So if you know your y-intercept, you can easily find another point because it's an equal distance on the other side of the axis of symmetry. So I don't want to go forward until everyone's done writing down. Aiden's usually good about telling me. Let me know when you're done. Are you done writing? What's it? Almost. Okay. Am I in the way? Here, is this better?
I got it.
Okay. Okay, great. Okay. I'll just hide. Got it? Okay. Still writing? Okay. All right. So now we're going to look at our equation in a slightly different format. Where it looks like this: y equals some number times x minus a number squared plus another number. I want you to divide and conquer in your group and summarize the data for each of these. And we're going to notice some patterns here. So divide and conquer and summarize these points. Okay, Desmos, do that now.
There's gonna be a minimum. And that's all. So that's only. There's a minimum because the parabola. Yeah, what are you trying to? Like, the minimum is just like the vertex.
We didn't find it in this format, right? I don't think we learned anything else this year.
We used like the formula to find. It was like the y-intercept.
Oh, the y-intercept? It wasn't quadratics though, I don't think. Was it?
I don't know.
No, I think you're thinking about absolute value functions. Yeah. Yes. Yes, Desmos. Yes, Desmos, people, Desmos. It says that in writing too. Investigate the following functions on Desmos. I know, I know. Dividing and conquering. Well, there's a vertex. Yes. Right. The vertex would be x equals to x squared. Okay, we should be getting to a point where we have this compiled. Okay. Now, there are some observations to be made here. Notice that the vertex, when it's in this form, is h comma k, right? Well, that's pretty nice. If you can look at this equation and know right away the vertex is at 3, -5, -1, -4, -2, 7, and 5, 10. Pretty nice. For that reason, we call this vertex form. It's the vertex form of the equation. If the a value in front is positive, it opens up. If it's negative, it opens down. As always, the axis of symmetry, or AOS, is x equals the x value of the vertex. Some of these zeros were not so pretty. Look at this. There were some imaginary zeros there. As far as your x-intercepts go, when there are imaginary zeros, what can be said? How many x-intercepts are there? Graph. None. None. Okay. Any questions? So now that we've done that, we should be able to graph a function in vertex form, and I'd like to help you with that on the next page. But I want to make sure you're also done writing down anything that needs to happen. Yeah, Adriana.
For the vertex for H, do you switch the sign?
Yeah, notice the vertex form is x minus h. So it's the opposite of what's in here. Anything else? What's wrong? What's wrong? Okay, so let's do this one together. The first thing I'm going to do is identify the vertex. The vertex is at 1, -4. And I'm going to plot that. Right there. My axis of symmetry is x equals 1. It's the x equals the x coordinate of my vertex. Now, when things are in the other form, it's easier to see what those x-intercepts are. Not as easy here. To find the x-intercepts, you set the function equal to 0. To find the y-intercept, you plug in 0 for x. So think about it. Anywhere on this x-axis, your function is equal to 0. So you set your function equal to 0, solve for x. Anywhere on the y-axis, x is equal to 0. So you put in 0 for x and solve for y. So I'm going to find the zeros or the x-intercepts by doing this. And I'll add 4 to both sides. And then take the square root. So 1 plus or minus 2. So my x-intercepts would be -1, 0, and 3, 0. So plot that. -1, 0, and 3, 0. So now let's look at these and make sure that they make sense in terms of where those zeros are. So if my zeros are here and here, my vertex should be exactly halfway between. Sure enough, they are. It is. If it wasn't, I would know I made an error somewhere. To find the y-intercept, I'm going to put in 0 for x. One minus 4 or minus 3. So 0 minus 3 is my y-intercept. Now I'm going to use my axis of symmetry. I'll even draw it in. So if I have a point that is 1 to the left, I will have another point that is also 1 to the right. And then I will draw in my parabola like so. Any questions? Hopefully it's not too bad, right? Okay, why don't you guys try doing this one? Notice it's not in vertex form, it's in standard form. So find the zeros, find your y-intercept, find your vertex, and graph. Do this, and then we'll go over that. And then you guys can start on your assignment, or it will be time to go, one or the other. You know what? Sure. Got it? I do, I write ordered pairs, but if someone asked me to zeros, I would say it's at -1 and also 3. My zeros are -1 and 3. My x-intercepts are ordered pairs. It's a subtle difference. When you're done, share with your neighbor. Put your stylus down so I know you're done, or your pencil. Okay. Here are my answers. So found the zeros. I found my X value halfway between, like so. My X value, my vertex is a quarter. To find the Y value, you plug back in. You know how you all look at it, right? The times. How to get 49/8 this way. So put in, it's possible I have an error. Let's check. So let's put in 1/4. Okay, let's check. So this is 2 times 1/16 minus 1/4 minus 6. That would be 1/8 minus 2/8 minus 48/8, right? So, no, that's right. Minus 49/8. So common denominator here, multiply by 8/8. Then I subtract, and then I add my numerators. 1 minus plus a -2 plus a -48 minus 49. Make sense? Mm-hmm. Okay. All right. So any other questions on this? Right. The assignment is posted online. Make sure you do that. Again, our next quiz will be next week on Friday.